So, register is, we know what is a bit. Bit is either 0 or 1. What n bit register means what? It stores n bits, no. Okay, no, classical n bit register means it stores n bits. So, here we can talk about quantum register similar to that. It stores qubits. Classical register stores bits, here it stores qubits. Okay. Here we talk about size. Size means number of bits it contains, no. So, here size means number of qubits, okay, no. But initially all qubits they are assumed to be in state 0, ket 0. Now, this is a quantum circuit, general form of quantum circuit. We have some input, we have some quantum gates, all are what type of matrices? Quantum gate or quantum operation represented by unitary matrix, and here there may be multiple gates. Then we will get some final quantum state here. Once we go for measurement, then we will get a classical output here. Result 1, result 2, result n, they are classical outputs. After measurement only we get classical output, otherwise still it is quantum state. That is why this is measurement symbol. Okay. Now, this is one quantum circuit. Here H for Hadamard gate. What is matrix for that? 1 by root 2, 1 by root 2, 1 by root 2, last one is minus 1 by root 2. Similarly, X is one gate. UF gate, that I will tell you, okay, now after some time what is UF gate, that you will understand. Similarly, this is control, okay, no? Yesterday's class madam explained what is control NOT gate, okay, that I will explain now, okay. Now, Hadamard gate, this is the matrix, no? So, this is a circuit. What is Hadamard on ket 0? All of you calculate and tell me. What is Hadamard on ket 0? Or what is the state here? Both are same, no? What is Hadamard matrix? Matrix you write down. 1 by root 2, 1 by root 2, 1 by root 2, minus 1 by root 2. What is ket 0? Thank you very much, madam. Okay. What is ket 0? 1 0 is the matrix. You multiply both. See, this is the matrix for H, Hadamard. This is ket 0, no? Ket 0 is a column matrix. So, if you multiply, you will get 1 by root 2, 1 by root 2. This 1 by root 2, 1 by root 2, we can write it as, we can write it like this, which is same as 1 by root 2. If I take common here, it is 1 0. If I take 1 by root 2 common here, it is 0 1. So, this is 1 by root 2. What is 1 0? Ket 0. What is this 0 1? Ket 1. This is also known as ket plus tet. Is that okay? This is Hadamard gate. See, this is normal. Once you know what is matrix for that gate, that operation, after that it is normal matrix multiplication only, no, nothing. And you should know what is the definition of direct notation, ket and broad notation, that is all, nothing new here. Okay. Now, if I go for measurement, what is the probability of getting 0? Not 1. If this is alpha ket 0 plus beta ket 1 form, no? If I go for measurement, what is the probability of getting 0? It is mod alpha square. This is 1 by root 2 square, that is 1 by 2. Similarly, what is the probability of getting 1 here? 1 by root 2 whole square, it is again 1 by 2. So, what is this? This is called superposition state, but it is special, it is equal superposition state. Means probability of 0 is same as probability of 1, that is why equal superposition state. Measurement gives 0 with probability how much? 1 by 2, not 1. 1 with probability 1 by 2. Okay? Now, similarly, can you do it for 1? What is the answer? 1 by root 2? 1 by root 2 ket 0 minus 1 by root 2 ket 1. What is the probability of, this is called minus state, the other name minus state. What is the probability of getting 0? 1 by 2. What is the probability of getting 1? 1 by minus 1 by root 2 whole square, that is again 1 by 2. Is it okay? Okay. Now what is the, determine the output of the quantum circuit here. We have multiple gates, no? This is one circuit. In between whatever is there, some gates they put, finally measurement will get output, that is all. General form if you see here. Correct? No. Here some input is there, you put some number of gates here. Then finally you go for measurement, you will get output. So now you tell me, I don't explain, can you understand what is that we need to do first? 0, this is state 0, time stamp t0. At that time, what is the state? That is ket 0. What is, this is say, let us say time stamp t1. What is the answer we get there? Hadamard gate we need to apply to input state, that is ket 0. Whatever answer we get, that is the next quantum state. This is say t2. What is the state here? Whatever state we got here. Whatever state we got here. What, this is a T1, T2 like this. What is state at T1? T0? Ket 0. What is state at T1? Hadamard on ket 0, which is same as 1 by root 2 ket 0 plus 1 by root 2 ket 1. This is the state here. This is the state here. What is state here? That is X gate we need to apply. Here we have to apply X gate to 1 by root 2 ket 0 plus 1 by root 2 ket 1. We have already seen now, if it is alpha ket 0 plus beta ket 1, what happens? These two gets interchanged. So it is again 1 by root 2 ket 0 plus 1 by root 2 ket 1. That's all. Is that okay? Okay, so more detailed explanation is here, you can see if you want. T0, what is the state? T1, H on ket 0. T2, X of H of ket 0. H of ket 0. Okay, is that okay? H of ket 0 is this, H is this, what is ket 0? 1 0. Answer is this. Is that okay? This is the answer, H of ket 0. This value we give it to X. H of ket 0, T1. Now T2, what is the state? X of this. What happens? These two are interchanged. Otherwise, X of ket 1 by root 2 X of ket 0 plus 1 by root 2 X of ket 1. X of ket 0 is ket 1, X of ket 1 is ket 0. Is that okay? Okay. Now if I go for measurement, what is the probability of getting 0? Tell me, madam. This one, this state only. If we give? No. Ket 0 becomes ket 1, ket 1 becomes ket 0, that's all. Not minus sign is not, that minus sign is required, no. Ket 0 becomes ket 1 becomes ket 0. Is that okay? Now measurement gives 0 with probability how much? 1 by 2, 1 by root 2 whole square. 1 with probability? 1 by 2. Is that okay? Now this is one way. Now again, for example, here instead of 0, if 1 is there, then what should we do? Again from starting everything we need to do now. See, this value will change, this value will change, this everything will change, Instead of that, once you find all quantum gates which are present, if it is possible, you find only one unitary matrix corresponding to all gates applied there. Then any new input also directly that matrix I will multiply, I will get answer now. Are you getting? Okay, let us go back to this example. Let us see with this example again. Here, first which matrix is, which gate is performed? Hadamard gate. First you write that in the reverse order. In the circuit, whatever order is given, here it is reverse order. Next, this gate is applied. You multiply both x and h, find the product. H is this, x is this. First, h and x product is this. This is the product now. Okay. Whatever answer we get, maybe I think this is correct. This answer, this is the final matrix. This is the final matrix. 1 by root 2 minus 1 by root 2, 1 by root 2, 1 by root 2. This is the final matrix. Is that okay? Now, if you want on ket 0, directly what is that we do? You can easily check whether it is unitary matrix or not. Okay. When ket 0 is input, then what is that we do? This matrix ket 0 we multiply. What is ket 0? 1 0, 1 0. So this is the answer we got. 1 by root 2 ket 0 plus 1 by root 2 ket 1. Same thing we got it using the other method. No. Here what is the advantage of this method too? If input is different, for that input also easily we can calculate. For example, this input, if I had gone by first method, again from starting everything I need to do now. Now here what is there? Directly I use that matrix x h. X h is already given to me. This is given to me. Then what is that? I will put ket 1. Is that okay? Then multiply. This is the answer we got. It is easy, no? Okay. This is other method. If you are given a circuit, you can do it that way or this way. So 0 with minus 1 y root 2 whole square, that is 1 by 2, 1 with 1 by root 2 whole square. So in general it is given, then this method is better. Okay. So we have two systems. Let us say we have the first system is, say, let us say x, same notation I use, and the second system is y. Its classical states are, say, 1, 2. Okay, use 0, 1. Its classical states are A, B. What are the classical states of this combined system? 0A, it is given by Cartesian product of these two matrices, these two sets. This set and this set, the Cartesian product of this gives the classical states of this combined system xy. So what are they? 0A, but here ordering is important. Okay, you can put it 0B, 1A, 1B. That's what is written here. Okay, no? That's what is written. We have two systems x and y. First system classical state is sigma, second system classical state is gamma. The classical state of combined system is given by Cartesian product of individual classical state sets. Is that okay? Now this is not, it is a 2 qubit gate. Okay, it is not single qubit gate. Hadamard gate is single qubit gate. X gate also single qubit gate, but C naught stands for controlled NOT. This is 2 qubit gate. Okay, na? The matrix for this the matrix for this is this operation you try to understand. What does it do? This is control, this is target. Here control, target. If a target is 1, last class also madam explained, you remember. If target is 1, it flips this. Sorry. If control is 1, it flips this target. In this case, control is 1 or 0, this is input, this is output. Control is 1 or 0? 0. So, control and target as it is we get. If it is 0, 1, same. 1, 0, 1, 1, 1, 1, 1, 0. If control is 1, target is flipped. Is that okay? So, this is the operation of, this is the operation of control NOT, C naught. Okay, thank you. C naught operation. This is 2 qubit gate, whatever is shown here, no? And this is the matrix. How this matrix, no? Any control operations you can easily remember. Here first, this is 2 qubit, no? Here you put identity matrix here. This is identity matrix, 2 by 2 matrix. 2 qubit means 4 by 4 matrix we get, no. This is 2 by 2 matrix. Here all 0 matrices. 0 matrix order 2 by 2. Here it is which operation we are performing not? Control is for not operation, no. What is the matrix for not operation? This you can extend to any. Now if you want control not. This is for control not matrix. This is identity, this is 0 matrix 2 by 2, identity 2 by 2, 0 matrix 2 by 2, this is corresponding X operation. This is the matrix. Is that okay? This is one way. The other way is by seeing output you can see input, corresponding entry you can put 1. But control this matrix, this is even simpler. If I talk about control not, what is that you do? Control not a 3 qubit operation, no. So what is that we get? 8 by 8 means 4 by 4, 4 by 4, 4 by 4, 4 by 4. This is control not. C naught matrix you write here. This entire thing you copy here. Here what is that you write? 4 by 4 identity. Here 4 by 4, 16 zeros you write here, 16 zeros here, 16 zeros but main diagonal 1. That's all. That is control. Like this, now you can write control by operation. What is the matrix? Control Z also you can write. Are you getting? Any control operation you can write matrix, no, easily. Are you? Okay. Now this matrix is same, no? 4 parts if you do, we'll get this only, no? And this is the gate circuit diagram for this. First one is control, second one is target. Why this plus symbol, plus type, XOR type? The output whatever we get, that is XOR of 2 inputs. If you see here, what is 1 plus 1? 1 XOR 1. XOR operation is both bits are different, we will get 1, otherwise 0. 1 XOR 1 is 0, that's why target is 0. Control is same. Whatever control is here same, this column and this column both are same, no, ditto we have written, only target only changed, that's all. Are you? So 1 0 1 0 1 1 0 0 0. Why, this is target, why this symbol, is it clear? Okay. First one is control, this target is XOR symbol. Now what is C naught and ket 0 0? What is the answer we get? 0 0 only. How this matrix we know, what is C naught matrix, this matrix, 0 0 is the matrix. So 0 0 means 2 qubits, no. It is like this is 1, this is 1. What are the classical states of this combined system? 0, 0, 0, 1, 1, 0, 1, 1 in the same order. Here this is the order, here this is the order, this is the order here. Now I am talking about 0, 0. 0, 0 is first one. What is the corresponding matrix? 1, 0 means it is third one. Third one means third place 0, 1. Is that okay? So C naught and ket 0, 0. C naught means this matrix. 0, 0 means 1, 0, 0, this matrix. You multiply both. What is that you get? Again same thing you get. So similarly C naught on, what is C naught on 1, 0? 1, 0 you know, no. 1, 0 means third one. Third one means this is the matrix. Is that okay? 1, 0 is nothing but 1, 1. 1 means control is 1. First one is control. Control is 1, target is changed. 0 becomes 1. If whether control is 1, target change, if you don't remember that, target you make XOR of input. Control as it is you retain, target is XOR of input. Automatically you will get the same answer. Is that okay? See, 1, 1. If I go for measurement, what is the probability of getting 1, 0, 0? We don't get 0, 0, no. 0. Are we getting 0, 1? No. Are you getting 1, 0? Are you getting 1, 1? With the probability 1. Okay. Now we have two systems. First system classical states are 1, 2, 3. Second system 0, 1. What are the classical states of combined system? It's Cartesian product. 1, 0, 1, 1, 2, 0, 2, 1, 3, 0, 3, 1 like this. Okay. Now if it is the Cartesian product for this combined system, that means it contains 6 possible outcomes, no. The corresponding matrix should contain 6 rows and 6 columns. This is one sample matrix. I just want to show that if I am talking about 2 qubit system, it should have 2 by 2. So how why 2 by 2? There are 4 possible options. 2 qubit system means there are 4 possible outcomes. That's why it is 4 by 4. If it is 6 by 6 system, then 6 by 6 matrix we should have. No. I am talking about qubit system, then definitely we will not get like this 2 by 2, 4 by 4, 8 by 8, 2 power n type we get. Why? Because every system 2, 2 only. No. Qubit means only 2 possibilities should be there. What is U on 1, 1? U means this is the matrix. 1, 1 means what? 1, 1 is here, second position. What is the column matrix? 1, 0, 1, 4 zeros. You multiply this, whatever answer you get, that is the answer. Are you, in general, how to calculate, okay? Now if I go for measurement, what is the probability of getting 1, 1? 1 by 4, not 1 by 2. I by 2 square, no, mod I by 2 square, 1 by 4. What is the all are 1 by 2, 1 by 4 only. Okay, you can calculate anyhow. Now you are performing an operation on one system, independently some other operation, same operation or some other operation on other system. What is the combined action of these 2 operations on the combined system? X is one system, Y is another system. On system X I am performing some operation, system Y I am performing some other operation. Now X and Y system I am seeing it as a single system. Then what is the operation on this combined system? It is given by tensor product of individual operations. Tensor product of individual operations. Okay, these are different alternate notations. We will come back to this. First let us see. What is tensor product of these 2? So in order to get A, B, C, D, this is tensor product symbol. In order to get tensor product, first matrix you write as it is. A, B, no. Next to each entry of first matrix, you copy second matrix. Second matrix is CD, second matrix is CD. See, first matrix as it is I have taken. Next to each entry of first matrix I have copied second matrix. Now what next I need to do is, you multiply corresponding entries and the same position you put AC, AD, BC, BD. This is the result of this tensor product. Okay, na? So maybe what is tensor product of this? V1 W2, V1 W3, V2 W1, single column matrix. Is that okay? What is answer for this? Alpha 1 beta 2 and so on, alpha 1 beta k. Next alpha 2 beta 1 and so on up to beta k. Next alpha 3 beta 1 and so on up to beta k. Is this okay? Alpha 1 to alpha beta 1 to beta k. After that alpha 2 starts, beta 1 to beta k. Next alpha 3 starts and so on, alpha m starts beta 1 to beta k. Is that okay? In general, what is tensor product of two Hadamard matrices? What is a tensor product of two Hadamard matrices? We need this answer. We use this tensor product of two Hadamard matrices. What is a Hadamard matrix? 1 by root 2, 1 by root 2, 1 by root 2 minus 1 by root 2. This is okay. Now here again same matrix, no, 1 by root 2, 1 by root 2, 1 by root 2 minus 1 by root 2. This entire matrix you copy. First matrix all entries I have written. Against each entry of first matrix, second matrix as it is you copy. Now what is next step? Correspond this element, multiply with this scalar 1 by root 2 into 1 by root 2. Next to 1 by root 2, next position 1 by root 2, 1 by root 2 next row, no, this is first row, this is second row, 1 by root 2, 1 by root 2, 1 by root 2 minus 1 by root 2, like that you can multiply, okay. So like, is it okay? Here 1 by root 2 is taken outside, but if you multiply finally this answer you get. This is 1 by 2, all entries are same. This is 1 by 2, 1 by 2, 1 by 2 minus 1 by 2. See, this 1 by 2 is taken outside, 1 by 2, 1 by 2, 1 by 2 minus 1 by 2. 1 by 2, 1 by 2, 1 by 2 minus 1 by 2. 1 by 2, 1 by 2, 1 by 2 minus 1 by 2. Last one, what is last these two entries? 1 by root 2 into 1 by root 2 minus 1 by root 2 into 1 by root 2 minus 1 by root 2 into 1 by root 2 minus 1 by root 2 into 1 by root 2. So it sign changes, that's all. 1 by 2, 1 by 2, 1 by 2 minus 1 by 2. Is that okay? This is tensor product, okay. Okay. Now for example, I am performing action on two systems. First system I am not performing any operation. Second system I am performing Hadamard operation. What is the combined action? Not performing anything is identity 1001. We are not changing anything 1001. So 1001. Second system Hadamard. This is the combined action. Now first system Hadamard. Second system I am not. This is the first system identity, no one. First system identity, second system Hadamard. Similarly, ulta, if for example first system Hadamard, second system identity, identity means not performing anything. H tensor identity, one, that is identity. Okay. Now you look at this state. This is a state of 2-qubit system or not? Is it a valid state of 2-qubit system? Is it a valid state of 2-qubit system? what is the condition it has to satisfy? 1 by mod 1 by 2 whole square plus mod I by 2 whole square plus mod minus 1 by 2 whole square plus mod minus I by 2 whole square is 1. That is the condition it has to satisfy. Is that okay? It is satisfying. It is a valid 2 qubit system, okay, a valid quantum state, valid quantum state. Now, so whether this state is independent or not. That means the corresponding systems x and y, that means you are performing some operation on system x, independently some operation on system y, that means there is no relation between the two. One is not going to affect the other one. So when do we say that? When do we say that? Now, is it possible to write it as, see, is it possible to write it as tensor product of that individual system states? If at all you are able to write this entire state as tensor product of individual system states, then we say that they are independent, no? Then we say that they are independent. That means you need to find two states. This is one state, tensor product, another state. This tensor product value, if it is ket pi, this is first system x, second system y. Here some valid state, here state, valid state. If you can write it like this, then we say that they are independent. Is it possible to write it that way? See, now let us write it like this. 1 by root 2 ket 0 minus 1 by root 2 ket 1 tensor 1 by root 2 ket 0 plus I by root 2 ket 1. Okay. What is the matrix form of this? What is matrix form of this? 1 by root 2 minus 1 by root 2, no? What is matrix form of this? I by root 2. This is 2 qubit system, means this is also quantum system, qubit system. This is class outcomes are 0, 1. This also outcome. What are the outcomes of combined system xy? 0, 0, 0, 1, 1, 0, 1, 1. These are the outcomes of given by Cartesian product of the two. Okay. Now, what is this tensor product? 1 by root 2 into 1 by root 2 direct 1 by root 2 into 1 by root 2, 1 by root 2 into I by root 2. This one with both, no. After completing, second entry with what is this value? 1 by 2 I by 2 minus 1 by 2 minus I by 2. Okay. This is 0, 0, this is 0, 1, 1, 0, 1, 1. This is the order, no? Can you write it as 1 by 2 times ket 0, 0 plus I by 2 times ket 0, 1 plus minus 1 by 2 times ket 1, 0 minus I by 2 times ket 1, 1. Correct? No. That means we are able to write it this way. Then we say that these are independent. X and Y are independent systems. Once you know what is tensor product, after that given a state, whether you are able to write it as tensor product of individual system states. If you are able to write, then we say that they are independent, otherwise they are not independent. They are not independent. So, this is the first system state, this is the second system state. They are not independent. Now, is it possible to write it this state it is impossible to write. if you are not able to write a state as tensor product of individual system states, then we say that they are the corresponding systems, they are not related. Then we say that there is a kind of correlation or relation between them, and that is called entangled states or entanglement. Finally, what is entanglement? So whatever we speak, finally mathematically we should be able to represent, no. So if state of system, okay, if you are not able to write it as tensor product of individual system states, then we say that there is a kind of correlation or relation between those states, and say that they are not independent. That means we say that they are entangled, otherwise they are not entangled. This is an example for proof I am not doing, okay, no? Okay. Well, if you want to, you can try, okay. 1 minute. If by contradiction, if it exists, these are called Bell states. So, for example, there exist two states, alpha ket 0 plus beta ket 1, and another state ket pi alpha 2 ket 0 plus beta 2 ket 1. By contradiction, I am assuming that there exist two states like this. Then what should happen? Beta 1 ket 1 tensor product with alpha 2 ket 0 plus beta 2 ket 1. Okay, if you calculate tensor product directly also you can, it is like normal multiplication you do, that only tensor product, alpha 1 alpha 2 ket 0 0. So this notation why I am giving, no, ket 0, either we can write it this way or we can write it this way, or we can say that this is a first system, this is second system, explicitly we can mention. That notation, multiple ways of referring that. These are tensor product, different textbooks, different authors use different notation. If they explicitly mention this symbol, okay. Otherwise, directly they write without mentioning, or they put both together in one ket, that is also okay. Comma separated, okay. This way also okay. All are same, however they use. That means what means? Ket 0, tensor ket 0, both are same. These are not. Why? Because this is third form, this is first form. Both are same only, no. Alternate ways of representing, okay. So this will get alpha 1 beta 2 ket 0 1, beta 1 alpha 2 ket 1 0, beta 1 beta 2 ket 1 1. Is this okay? Now what is our given state? This is given state. What is the coefficient of ket 0 0? What is this value? 1 by root 2. What is coefficient of this? This is, see, alpha 1 beta 2 is 0. That means what are the possibilities? When does alpha 1 beta 2 become 0? Alpha 1 is 0, beta 2 is 0. Alpha 1 is 0 or beta 2 is 0. If alpha 1 is 0, whether it can be 1 by 2? No, this becomes wrong. If beta 2 is 0, whether it can be 1 by 2? No, that means we will get a contradiction. Hence, we show that it is impossible to write it as tensor product of individual states. Okay, anyhow, other things I need to discuss, that's why I'm, okay. Now, is it an entangled state or not? It is entangled state. So, like that in between if I put minus, that is also entangled. No change, except for sign. 1 by root 2 ket 0 1 plus ket 1 0. That is also entangled state. Okay, later you can check. They are called Bell states. Okay, if you want to, you can write down this. They are called Bell states. Now, what is the output of this? Now, only 5 minutes for this circuit parts. Next, we move on to other part. Okay. What is the output of this? First we need to know what is the state at T naught. No. That's why I explained tensor product, no? Thank you very much, sir. Okay. So it is, we have two qubit system, not a single qubit system, no, here. So first system, what is the state, initial state, first part, top part, ket 0. Second part, ket 1. What is the combined state? What is the combined state? It is, we can write it like this. Either you can write it like this, both are same. Either you can write it this way, or you can write it this way, or sometimes 2 zeros means people write it 0 square like this also. 0 square means 2 zeros. This also okay. Is it okay? Now, this is a combined system, but okay. So let us follow one notation. Ket 0, let us suppose you have written like this, or ket 0, this way also we can write now. Anyway, you should not have any confusion. Now, first qubit, which gate you are applying? Hadamard gate. You can apply Hadamard gate. Second gate, Hadamard gate. Whatever result you get, for that again you should take first tensor product. Here, second gate also you are applying Hadamard gate. After that, some other circuit. Here, what is the answer we get? Ket plus. Here, what is the answer we get? Ket plus. Now, what is the combined state of the system here? Ket plus, tensor ket plus. Or to be more specific, 1 by root 2 ket 0, 1 by root 2 ket 1, tensor root 2 ket 0 plus 1 by root 2 ket 1. Is that okay? Now, if you want, you can simplify that. This is nothing but 1 by 2 ket 0, 0 plus 1 by 2 ket 0, 1 plus 1 by 2 ket 1, 0 plus 1 by 2. If you do it, you will get like this. If you after simplification, that you can complete it. 1 by 2 ket 0, 0, 1 by 2 ket 0, 1, 1 by 2 ket 1, 0, like this. After that, which gate you need to apply? Control NOT gate. So now control NOT gate we know. This is a control NOT gate, no? So now if you apply 0, control NOT to 0, 0, what is that you get? 0, 0, no change here. 0, 1, no change. 1, 0, 1, 1, 1, 1, 1, 0. Finally, answer changes. Changes, but the same value. This has come here, this has gone there. So finally, what is the answer? At T2, what is the answer? 1 by 2 ket 0, 0 plus 1 by 2 ket 0, 1 plus 1 by 2 ket 1, 1 plus 1 by 2 ket 1, 0. Is that okay? Or for each of this, I applied controlled NOT gate. Control NOT 0, 0 becomes 0, 0, 0, 1 becomes 0, 1, like this. Is that okay? Now, what is next step? Again, Hadamard gate you need to apply. So again, there are two ways. One is, this is 2 qubit, no? This is, so now you have 1 qubit gate here, 1 qubit gate here. How to apply? If you want to apply Hadamard only one, you need single qubit gate. But both at a time, if you want to apply Hadamard, tensor Hadamard you take. Are you? Then you can directly apply. Hadamard, tensor Hadamard, already we have calculated the matrix, no? If you want to apply singly, how do you apply? 1 by 2 ket 0, you write it this way. It is like this. Now here you apply Hadamard, here you apply Hadamard separately, that is your wish. There are not a single unique way, no, there are multiple ways of calculating the output. However you want, you can do. Okay. So Hadamard tensor. Now, what is the other method I explained? In reverse way. So first, what is the operation? One single matrix for all operations. What is single matrix for this all three operations? What is the matrix corresponding to this? Hadamard, tensor, Hadamard. This is control naught, C naught. This is Hadamard, tensor, Hadamard. You write the three matrices and find the product. Hadamard, this matrix is here. This matrix is C naught. This matrix is Hadamard, tensor, Hadamard, tensor, Hadamard. This is the matrix. Similarly, C naught, this is the matrix. Hadamard, tensor, Hadamard. This is the final operation corresponding to this entire circuit part. After that, what is next step? Whatever input they have given, 0, 0 is the input. 0, 0 means column vector with 1, 0, 0, no? You multiply both, oh, finally we are getting 0, 0 only. Is that the procedure clear? Okay. Okay, that is procedure. So what is Hadamard on ket 0? This is only for a revision type. This we use. Okay. No. Plus 1 by root 2 ket 1. 1 by root 2 ket 0 plus 1 by root 2 ket 1. Hadamard on ket 0 is 1 by root 2 ket 0 plus root 2 ket 1. The other name for this is ket plus. Okay, that is leave it. Okay. This can we write? Okay. Now, can you calculate what is this value? Can you guess what is this Hadamard square tensor 2? Hadamard tensor 2. What is that value? Hadamard tensor with Hadamard. That is another way of writing that. Now, you tell me what is Hadamard tensor Hadamard? This we have already calculated, no? I think this is the matrix. This is the matrix, no? This is the matrix. So now by seeing that matrix, can you tell me what is Hadamard tensor Hadamard? Hadamard ket 0, 0. What is this value? That matrix with one. No. What is the order of this matrix? This is 4 by 4. This is 4 by 1. So 4 by 1 matrix we get, no? 1 by 2, 1 by 2, 1 by 2, 1. Okay, later you can multiply, we will get this. Okay? So this one we can write it as by taking 1 by 2 common, 1, 1, 1. Is that okay? Now, because we have already discussed earlier how to represent it and all, okay, no? Now, can you write it this like this? 1 by 2, 1 000 plus 1 by 2, 0 1 00 plus 1 by 2, 0 0 1 0 plus 1 by 2. Is this correct? So, what is this? Now, I think because I have already explained that the fan switch and Aditya University, second MTech CSC, what are the options, BTech CSC, AADS, CSIT. If you have really understood those things, this you should be able to follow. What is this matrices, no? Is that okay? Now, what is the probability of getting 0, 0? If I go for measurement, 0, 1, 1, 0, 1, 1. Each state it has equal probability. Each outcome has equal probability. That is called equal superposition state. Is it equal superposition state? All possible outcomes are there. 0 in case of single qubit system, 0, 1 are the possible outcomes. We have both outcomes. Each outcome we get with the same probability. So it is equal superposition state. Now I can simply write it. What are the bit strings possible with the 0, 1, whose length is 1? How many binary strings of length 1 possible? 2. 0 is one bit string, 1 is another bit string. How many binary strings of length 2 possible? Length 3 possible? Length 4? Okay. Now I use this notation. This is 0, 1, 0, 1 means this denotes length, this denotes length. Number of binary strings of length 2, binary strings of length 3, short notation. Can I write it like this? Sigma x belongs to 0, 1, 1 by root 2 I will take common, ket x. Is this correct? Is this correct? Okay, if you are confused, one more step. Ket 0 plus ket 1, do you agree with this? 1 by root 2 I have taken outside. Now 1 by root 2, I will take x belongs to 0, comma 1, ket x, do you agree? Okay. Now this can I write 1 by root 2 whole power 1, sigma x belongs to 0, 1 power 1. What is 0, 1 power 1 set? Length 1. Again it is 0, 1 whole square. X. Oh no, instead of writing the entire thing small, you can write it like this. Now what is this Hadamard operation tensor product doing on ket 0, 0? All possible states of that system it is putting in equal superposition. Are you? This is the answer we got, no? Now can you guess what is the answer for this? Without 0 is, is that okay? 1 by root 2 whole cubed means 2 root 2 only, no? All possible, all bit strings with 3, binary strings with of length 3, but a corresponding ket summation. What is the answer here? Directly you tell me. 1 by root 2 whole power 4, sigma x belongs to 0, 1 power 4, ket x. Explicitly if you want to write 1 by 4, 1 by root 2 whole power 4 is 1 by 4. Sigma x belongs to 0, 1 power 4, ket x. Now this is 0, 0, this also, this is 0 cubed, I can write now. 3, 3, 3, 3, 0, 0, 0, I can write it as 0 cube, 0 square, like that. Again 0 square means not multiplication, it is only notation purpose, notation. In textbooks you come across this. Is this okay? Okay. In general, what is Hadamard tensor n ket 0 power n? Power all possible n bit strings. How many bit strings we get? 2 power n. It puts in equal superposition. That means when I go for measurement, each state I get with equal probability. So in most of the algorithms, this is the first step. Initially, all solutions we take them as equally likely. Then solutions which give optimal value, their probabilities we increase. With solutions which give not that much optimal, their probabilities we reduce. Once algorithm is completed, better solutions, they are called probability, alpha, beta are called probability amplitudes. Better solutions amplitudes are increased. That means what? The other probabilities are reduced, no? Why? Because total probability is 1. Is that okay? Now what is the answer? That is the answer. Okay, if you have any difficulty, you can see this. Their calculation is also there. Nowadays, I need not give calculation. If you put in ChatGPT, it will give you however you want. Okay, no. But what is that we require? No, that I have. Now, if this background is required, then I can quickly explain algorithms without again referring to them whenever I get there. No, again I should come back, I should explain. That problem will not be there now. Directly, step by step, I can go. Surprisingly, quantum algorithm also, again it is one quantum circuit only. Whatever algorithms we are going to discuss, they are quantum circuits. Now you know what is quantum circuit, different operations, tensor product, Hadamard also. Now, we have some input. We perform some processing, that means some algorithms or instructions we write, so we get some output. Here also what? Same procedure. We have some input. Next, for some steps, okay, no. Then we will get some output. Output means we should go for measurement. Steps means what are the steps? Those are nothing but some quantum operations, no? They are classical operations, here quantum operations. And this algorithm, when do we call it as a quantum algorithm? When the steps or operations performed, they are based on the principles of quantum mechanics. Superposition, entanglement, okay, no, principles of quantum mechanics. An algorithm which is based on the principles of quantum mechanics, that is called quantum algorithm. Okay. So, finally, what is that you need to understand is the operations we perform are quantum operations. What are they? Again, we know some basic quantum operations we know, no? That is all. Input, but input, it is not classical input. What type of input we give? It is a quantum state. These operations, they change quantum state from one state to other state. Once the final state is calculated, we go for measurement. That measurement gives us a classical outcome. That is all. Okay. Now, next 5 to 10 minutes, again we need some basic things. Okay. Okay. One ka madam break. Okay. Okay, you only read this and tell me. I will give some examples. You should tell me whether it is a function or not. Definition is there. Anyhow, you also. We all have been studying it from 7th standard or 8th standard onwards. No, what is a function? Okay. Now, please tell me, is f a function from x to y or not? What is the condition that is violated? So, this condition, because this element it should have only one image, but multiple image, okay, na? It is like student guide allocation, project guide. One student, only one guide, no co-guide concept, remove that, okay. One student, only one guide, okay. So, this is not a function. What about this? So, what is the violation? What is the violation? Every student should get guide. I am going for internship means still there also industry guide will be there, here also Aditya also guide. Okay, this is also not allowed. What about this? Is H a function or not? Okay, this is doubt. F1, F2, oh same problem, no? Yeah. Okay, let us remove this. This is also a function. So, this is also a function. What does it say? Every student guide allocation? No, every student should have at least, no, every student only one guide. No student is left without guide. One particular faculty, he or she may guide multiple students, that is allowed. H is true, that is why I put question mark, not cross now. Here every element here it is mapped with some element, so this is also function. Now what are two violations? These two are the violations. Is that okay? Now what is a function? Is it clear? Okay. Now how many functions are possible from x to y? X is a set, y is another set. How many functions are possible from x to y? So any element you take, one student, he or she has how many options per guide? Any faculty he or she can go now. First student can go to any of the faculty. How many options are there? How many teachers are there? That many. Number of teachers here, let us say in computer science, 124. 124 faculty are there. So number of 124. Second student, assume that there is no limit on number of candidates a faculty can guide. 124. Now tell me what total how many? Okay. How many functions from here? A, B, C, here 1, 2, 3. How many functions are possible? Okay, let us put D for difference. This is X and this Y. How many functions are possible? One can be mapped with any of 4, 2 can be mapped with any 4, 3 can be mapped with any 4. But for me, if it is a function, one must be mapped. This condition should happen. Some mapping should be there, some mapping should be there, some mapping. This can occur in 4 ways. This can occur in 4 different ways. This can occur in 4 ways. But for me, first one also should happen, second one also should happen, third one also should happen. By simple product rule, it is 4 into 4 into 4, that is 4 cubed ways. Is that okay? What is 4? Number of elements in second matrix, second set. What is 3? Number of elements in first set. So total number of functions from x to y is cardinality of y whole power cardinality of x. Is that okay? Okay. And now you tell me how many functions are possible from 0, 1 to 0, 1? Cardinality of y whole power cardinality of x. Cardinality of y is 2. If you confusion also there, still you can give correct answer. Both are 2, 2, no? 4. What are they? Are these functions possible functions? 0 with 0, 0 with 1 with 0, 0 with 1, 1 with 1, 0 with 1. Okay, those are the 4 possible functions. Is that okay? All 4 possible functions from 0, 1 to 0, 1. How many functions are possible from 0, 1 square to 0, 1? 16. 2 power 4, 16. What are they? These are those 16 functions. Is that okay? Now, you look at, first we will confine our discussion to this function. Function from 0, 1 to 0, 1 only. 0, 1 to 0, 1. Here, what is the specialty of F1 and F4? What is special there? all inputs are mapped with the same element in the set Y, no? All students are going to one guide only, one person only, one faculty only. It is like that. Okay. In second case, out of this is 2 students, total 2 students are there. Out of that, 1 student is going to one faculty, other student going to another faculty. Is that okay? This type of function is called constant function. Constant means all are going to only one faculty. All students mapped with only one faculty. That is called constant. If the faculty name is 0, that is called constant 0 function. If the faculty name is 1, constant 1 function. All the elements are mapped with 1, then it is constant 1 function. If it is mapped with 0, then it is called constant 0 function. Now, what is constant function? Is it clear? F of x equal to c for all x's in the domain. Is that okay? That is called constant function. Now, the other one is, here what are constant functions? How many constant functions are possible? In the output only there are 2 outcome or 2 possibilities, 0, 1. How many constant functions are possible? Only 2, no, all mapped with 0 or all mapped with 1. They are F1 and F16, no? Not F16, I think, oh, here typing mistake then, that is mistake, okay. F1 and F16, this also should be 1, okay, that is my mistake, okay. F1 and F16, okay. Now, that is called constant. How many constant functions? 2. The other possibility is, half of the students are going to one faculty, other half going to some other faculty. Here only 0, 1, 2 faculties, no, 2 faculty members. Half of the students going to one faculty, remaining half are going to other faculty. Are there any such functions? F8. Out of 4, half is 2. 2 are going to one faculty, 2 are going to another faculty. Next, F6. F6, no. It is not half going to one faculty, half going to other. It is not that type. F14 also, F14 also. Now it is clear that is called balanced function. Constant function means f of x is some constant for all possible x's. Balanced function means f of x is 0 for half of the inputs and f of x is 1 for remaining half. Is that okay? What is constant and balanced function? Now you tell me why. F1 constant function or balanced? F2? F3? F4? Constant. Now constant balanced, is there any confusion with respect to 0, 1 to 0, 1? No confusion. Are there any functions from 0, 1 to 0, 1 which are neither constant nor balanced? No. Every function is either constant type or balanced type. The moment someone tells us that you are talking about a function which is from 0, 1 to 0, 1, we automatically know that it is either constant type function or balanced type. Why? Because other variety they are not at all possible in this case, but in this case they are possible. For example, if you take F9, it is neither constant nor balanced. Is that okay? Okay. Okay, this is definitions. Whatever I explained, the same thing is written. You can read later. Okay. What is another way of telling whether a function is constant or balanced in this case? If f of 0 equal to f of 1, can we say that it is a constant function? I am talking about a function from 0, 1 to 0, 1 only. 0, 1 to 0, 1. F of 0 is same as f of 1. Is it a constant function or not? Correct? No. Only 2 inputs. One is 0, other one is 1. Both in f of 0 equal to f of 1, what does it mean? Both inputs, they are giving the same output, no? They are mapped with the same element, no? So in this special case, if f of 0 is f of 1, the function is a constant function. If f of 0 is not equal to f of 1, the function is balanced function. Now you read this. If you have any doubt, you ask me. Okay. Now this is another, this is from 0 1 to 0 1, that is why function is specified here. Here function is not given, no, any function it is okay, but this is only in this case. Okay, this. Now we are going to see the first problem, that is Deutsch problem. That is what I mentioned, no, the first algorithm, Deutsch algorithm. Okay. So what is Deutsch problem? You only read and tell me what is that problem. So we are given a function f that is from 0 1 to 0 1 only, that they have mentioned, no. Now what is that we need to determine? Whether it is a constant or balanced, but with 100% we know that given function is either constant type or balanced type, no. Why? Because no other variety is possible in this case explicitly. If it is 0 1 square to 0 1, then we do not know, but in this case we can say that they have given additional guarantee, that promise that given function is either constant type or balanced type. Now what is that we need to find? That is what is the output here? What is that we need to say? It is out of these two, which is that we need to tell. Okay, constant or balanced we need to decide. Now how do you do it classically? So any problem we should be able to give one brute force algorithm. If we are not able to give brute force algorithm to solve problem, it means problem definition is not clear to us. Any problem in this world, okay, no, computational problem, we should be able to give at least one algorithm. If we fail to give, what does it mean? Oh, problem definition we have not understood. Irrespective of the running time, we have to give. Okay. Now what does it say? When do you say that a problem function is constant? F of 0 equal to f of 1. Okay. Now you assume that you have someone, okay, no, you are not you don't have provision to calculate what type of function f it is hidden from you, but if there is some block box, if you send 0, they will give you f of 0 value. If you send 1, they will give you f of 1 value, but they do not tell you how it is calculated, what is that function, they do not tell you all those details. It is like inquiry type. If you ask a question, they will give answer without, they do not tell no what is the process they have gone through. Okay? Query model we can consider it as query model. See, only 2 inputs we have now. Only 2 inputs. First you ask someone, if f of 0 is same as f of 1, what does it mean? Constant function. If f of 0 is different from f of 1, balance. That means if you know f of 0 value and f of 1 value, easily you can decide whether it is a constant or balanced. No? You compare both. Oh, f of 0 you got no value, f of 1 also if you get, you compare both are equal, means you say that it is constant, otherwise it is balanced. Okay. But who has to give you f of 0, f of 1 value? We do not have that function with us. If f of x is 2x plus 3, then we only can calculate for any x, no. But here it is Boolean function, not 2x plus 3, example purpose I gave. Okay, we should ask someone. Okay, they simply give, what is your input, you tell me, I will give you what is f of 0. If your input is 0, I will give you f of 0. I do not reveal other details. Is that okay? Now first you ask for the f of 0. What is f of 0? They have given f of 0 value. They have given f of 0 value. You have f of 0 value. Based on this, can you decide whether given function is constant or balanced? What are possibilities for f of 0? 0 or 1. Assume that they have given f of 0 is 0, this is one case. Only this case. They have given f of 0 as 0. Based on this, can you decide whether f is a constant function or balanced function? No. Why? It depends on f of 1 value. If f of 1 also 0, then it is constant, otherwise it is balanced. For example, they have given f of 0 as 1. Can you decide based on this whether f is a constant or balanced? No. First is not given. F of 0 is 1 is given. Based on that, is it possible to conclude whether? Not possible. Instead of that, they have given f of 1 as 1. No, f of 0 is not given. Only 1 is given. F of 1 is 1. Or f of 1 is 0 is given. With any one answer, it is impossible. No, one input. If you know f of x value for only one x, it is impossible to determine. No. But if you know, if not 1, what is the other option? Total number of inputs itself is 2. If we know for both inputs, automatically you compare. F of 0 they have given, f of 1 they have given. You compare both are equal means constant, otherwise it is balanced. Over. That means classically you require how many queries? 2. Minimum 2. With less than 2 it is impossible. We require 2 queries. Classically we require 2 queries. Okay, let us understand this classical algorithm. You see this, whether you understood or not, you tell me. That's what I discussed. Is it okay? Okay. Now the question is it possible to solve it using less than 2 queries? To determine whether function is constant or balanced, we require 2 queries. Now, is it possible to do it in less than 2 queries? Means not a 0 possible anyhow, at only 1 query. That is next question. Okay, now, this Deutsch problem, classical algorithm, any classical algorithm you take, we require 2 queries. Now, what this Deutsch algorithm does? It solves it using only 1 query. So, this is the query model of computation. The actual function is hidden. Okay, no, you get information about that function by querying that. Okay, no, there is some one block box, you send input x, f of x it gives you. Okay. Okay, anyhow, this we have discussed. What is quantum algorithm? It is same thing. It is a step-by-step procedure for solving a problem, but step-by-step procedure they use quantum operations which are based on the principles of quantum mechanics. Remaining everything is ditto, no, normal algorithm only, no, this one. That's what I mentioned already. So, this is one quantum algorithm. There is some input, it gives some output. Finally, there is a circuit or some gates, that's all. Now, these are some standard quantum algorithms, starting with this algorithm we are talking about now. Okay. Maybe at least some are going to be covered as part of this FDP. Some more 3 more days, no. Okay. Now, let me explain this Deutsch algorithm. I said it was in name itself says no, the problem and the algorithm. It was proposed by Deutsch in the year 1985. I have that photo also. It's a photo. What is special about? That's all. This is a algorithm for algorithm. This is algorithm. What is there? Oh. Now, what is that which you don't know here? Only UF. If UF, what is that? If I tell you, then remaining thing you only can do, no. You know how to calculate this part, you know how to calculate this part also, you know. Remaining everything you are aware of this, no. We have already discussed, no. Only UF I need to tell you. Now, Hadamard, only completion sake I put. What is Hadamard matrix? 1 by root 2, 1 by root 2, 1 by root 2 minus 1 by root 2. Hadamard on ket 0 is ket plus, that is 1 by root 2 ket 0 plus 1 by root 2 ket 1. Hadamard on ket 1 is ket minus, that is 1 by root 2 ket 0 minus 1 by root 2 ket 1. Okay. So, this is UF gate. Okay, now this is UF gate. So, you have 2 strings x, ket x and ket y. Here ket x as it is we get, here it will get y XOR f of x. ket of y XOR, okay, this we use multiple times, ket x and ket y, UF, ket x as it is we get, here we will get ket y XOR f of x. Okay. You know what is XOR operation. Okay, what is XOR operation? Now tell me what is ket 0 0? If I give this as input, what is the output we get? Ket 0 XOR. Is that okay? If it is y, correct? No. If it is 1, is that okay? Oh, sorry. Yeah, f of this one, no? F of 1 y. Okay, yes. Correct, no? Y XOR f of x. That's all. If we know x and y, automatically you can calculate what is the outcome of that. No, that much is enough. Okay. This is also what is that operation? Unitary operation. All quantum operations are unitary. This is also unitary. This is the circuit for Deutsch algorithm. Now we need to analyze this circuit. Now you tell me what is the first step? Okay. Let us put it this way: ket 0, ket 1, Hadamard, UF, ket h. Okay. Now let us call this is T0 timestamp 0, timestamp 1, timestamp 2, timestamp 3. What is state at T0? Ket 0 tensor ket 1. This is same as ket 0 ket 1, even if you write it this way also fine. Okay. What is T1? What is the state at T1? Hadamard on ket 0, Hadamard on ket 1. What is Hadamard on ket 0? Ket plus. This is so now there is another important thing. UF on ket x ket minus. Okay, no? Okay, directly. Okay. This is ket minus, no? Is that okay? Okay. Now what is T2? Okay, this we can simplify. It will be easy, no? Instead of putting it, this is 1 by root 2 ket 0 plus 1 by root 2 ket 1 tensor 1 by root 2 ket 0 minus 1 by root 2 ket 1. This we can write it as 1 by 2 we can say ket 0 0. Is that okay? This term and this term, that's what I have written here. This term and this term, what is this? Minus 1 by 2 ket 0 1. Next this term and this term, what is the answer? Is that okay? 1 by root 2 square is 1 by 2. Now what is state at T2? Okay, if this is psi 1 or psi 0, ket psi 0, this is say ket psi 1. What is state at T2? UF on ket psi 1. This is, let us call it as psi 2 state. T2 psi 2, T1 psi 1. What is UF get you need to apply? UF1, is that okay? What is 0, 0? UF1 ket 0, 0. So now by linearity you can expand this, no? What is UF1 ket 0, 0? Is that okay? Is that okay? Now what is UF1 ket 0, 0? Okay. So here 0 I have, here also I have 0. This 0 as it is it comes, here we will get 0 XR, 0 XR f of 0. What is 0 XR with anything? 0 XR 0 is 0, 0 XR 1 is 1, hence we can write 0 XR any bit X or any Z is Z only. Correct now, where Z is a bit. Is that okay? Okay. Now here we can directly write this is same as is that okay? So here I can write 1 by 2 UF1 ket f of 0 minus 1 by 2 UF. What is ket 0, 1? Is this correct? X, X, Y, Y, XR, f of 0. Okay? I will write as it is. This is 1 XR f of 0. Is that okay? Plus 1 by 2 UF. Get 1, 0. 0 XR. What is 0 XR f of 1? 0 XR something is that only, no. 0 XR f of 1 I can simply write it as f of 1. So this one I can write it as ket of minus 1 by 2 UF. UF, oh sorry, no, no, now UF is not required, no. UF after calculation only. So what is 1, 1? Ket of 1 XR f of 1. Is that okay? Now up to UF we applied. Now up to now oh, we have not written that. Oh, okay, okay. So here, first one we should write, no madam. K to 0, here it is 0, 0, this is 0. Thank you, madam. Okay. Correct now. Zero, 0, 0, 1, 1, 0, 1, 1. Because both we should write, I actually forgot. Okay. Now this is state at T2, no? That is what we calculated. Now we need T3. Before that we make some assumptions about f. F can be what type of function? Constant or balanced. Again, in constant there are two possibilities, no? It may be constant 0 function, constant 1 function. So let us talk about this case. This I call it as case 1, this is case 2. Here again two cases. This is f of 0 is 0, f of 1 is 1. Here f of 0 is 1. Only these four possibilities, no? Constant 0 means f of 0 is 0, f of 1 is 0. This is one possibility. Constant 1 means 1, f of 1 is also 1. Now we talk about at least one case. Okay. So because what type of function given to us we don't know, we consider all possibilities. Four cases we have now. Case 1, case 2, case 3, case 4. So let us check. If at all I am talking about case 1, my function, given function is constant 0 function, constant 0 function. Okay. Then what happens? What is the state that I get? What is get psi 2? Constant 0 means what? That is f of 0 is, f of 1 is 0. Then you substitute f of, wherever f of 0 is there or f of 1 is there, you substitute 0. Then what happens? So here 1 by 2 ket 0, ket 0, f of 0 plus 0 minus 1 by 2 is that okay? Here if I substitute 0 I will get 1 now. So 1 1 I have written. Here if I get 0, this is 1 0 1, this is 1 0. Is that okay? Okay. Now what is, we can take something common. No. That's what I'm here. I am not getting this way. This one, no? This is correct only, no? 0 XR 1 1 only, no, madam? Here 1 0. This is also correct. Here this is 0 0 1. This is also correct. This is also correct. Correct only. One second. All 1. Okay, let us separate these two, and this 2 0 0 wala, that will 1 0 1 0, this term and this term I am writing first, okay, plus 1 by 2 ket 1 ket 0, next minus ket 0 ket 1, after this this minus, if I put like this I can put, is this okay? Okay. Now these two, second qubit is same, no? Okay, second qubit is same. Okay. So then what is that I can write? 1 by 2 ket 0 plus 1 by 2 ket 1. The second qubit I can take it outside, no? Is this okay? Is this okay? This one and this one I have put it outside. This entire thing is first qubit, this is second qubit. This is not valid qubit, okay, no, that I will adjust it, okay, right now let it be, next step it will be clear. Okay. Now here minus, here this is ket 1 1 no, similar to this I can take common no, 1 by 2 ket 0, is that okay? Is that okay? Now, so now what we can do is, okay, so this part we can take common no, and while taking common I will take 1 by root 2, 1 by root 2 outside, 1 by root 2 this 1 by 2 I write it, okay, it will be clear to you, 1 second, 1 by root 2 ket 1, I will take this will be 0, is this okay? Is this okay? Now this entire thing is again what? Common no? I can take common now. This is, if you know that it is ket plus. Okay, directly ket plus if I take outside, then what is remaining here? Ket 0 minus 1 by root 2 ket 1, ket minus. Is that okay? Okay. Now finally what is that we got? Finally ket plus psi 2 is ket plus ket. Now what is Hadamard on ket plus? Thank you very much. Hadamard on ket plus, Hadamard matrix you put, ket plus means 1 by root 2, 1 by root 2, you will get 1 0. Later you can calculate. So it is ket 0 and ket minus. Am I measuring both qubits? Only first qubit I am measuring, no. So you go for measurement. What is that we get? 0. I am measuring only top qubit. Bottom they have neglected, no, they are not measuring anything. Is that okay? Now if you go for measurement, if you get 0, what is the probability of getting 0? 1. First qubit only, what is the probability of getting 0? 1. If you get 0 with probability 1, or if you get 0, that means your given function is a constant function. Now how many times I use query get? This UF is called query get, whatever I said, no queries. This is query get. How many times we use this query get? Only 1 time. But there in classically minimum you require 2 times, no? So this Deutsch algorithm, it is able to solve this Deutsch problem using only 1 query, whereas in classical case we require, any computer you take, we require at least 2 queries based on classical computing. That is, this is the first trivial example, but a simple example where they showed that there are some things which we the quantum computers can do faster than classical computer. The first example, but practically this example, this problem is not used anywhere directly. It is only to demonstrate the power of this. Is that clear? Similarly, other case also you can try. You substitute this value. Again you get the same, after simplification you get same thing like this. You substitute this value, you will get here ket minus, ket minus. Ket minus means you get 1. When you get 1. So if you get 1, that means it is a balanced function. Similarly, fourth case also you get ket minus, ket minus. Is that okay? That's all. That is about the first quantum algorithm. Algorithm means finally what is normal circuit only, no. Only that gate, what all gates if you are familiar, then tensor product, all those things, then this is called circuit model. Okay, this will, after lunch we will start. It is continuation of this. Is it clear at least so far what is qubit, what is formal way of defining qubit, alpha ket 0 plus beta ket 1, what is the condition it has to satisfy, alpha mod alpha square plus mod beta square equals to 1. If I go for measurement, what is the probability of getting 0, mod alpha square, probability of getting 1, mod beta square. Okay. Ket 0, all these bro 0, they are column vectors. which satisfy property. What is the property? All are complex numbers and Euclidean norm is 1. Next we talked about given a state whether it is a valid quantum state or not, qubit or not, some different examples. Next examples where if I measure this quantum state, what is the outcome we get and what is the probability of getting that outcome, different examples we discuss. Next, what is the complex conjugate of a matrix, conjugate transpose of a matrix, then what is unitary matrix, what are different unitary matrices, based on that what is X gate, Hadamard gate, quantum NOT gate and C NOT gate we discuss. Okay, no? Through all operations are reversible, that is what I mentioned. Then based on that we have seen some circuits which involves single qubit as well as multi-qubit gates, that we simplified, and what are two different ways of calculating output, that also we discussed. Then with the help of that one simple quantum algorithm, that is Deutsch algorithm, that we were able to understand that circuit. Okay. Afternoon we will start with Deutsch Josa. Thank you.
Thank you, sir.
Thank you.
So let us take a lunch break, sir. Again, the session will start 2 p.m. The lunch break is 1 hour. The 1:45 the session again. Same venue.